In this presentation, we have to talk about the symmetry operations involved in an equilateral triangle. This belongs to C3V type. To understand more about an equilateral triangle, see this diagram. In an equilateral triangle, three sides are equal. The altitudes AF, BD and CE are called medians because in the case of an equilateral triangle, the altitudes divide the sides into two equal parts. Therefore, altitudes are the medians. This is a formula specifying angle of rotation. C suffix n is equal to 360 degrees by n. Here n stands for order of symmetry. Suppose n is equal to 3. The angle of rotation is 120 degree. If you provide 120 degree rotation to this triangle, we can get an equivalent triangle, equivalent structure. C32 stands for 240 degree rotation. Then C3 cube stands for 360 degree rotation. In the case of 360 degree rotation, we can harvest an identical structure. What is the difference between an equivalent structure and an identical structure? Come to this. This is an equilateral triangle. 1, 2 and 3 are the 3 points. Now, allow this triangle for 120 degree rotation about the vertical axis in the anticlockwise direction. Point 1 is shifted to this position, 2 is shifted to this position, the point 3 is shifted to this position. This is a newly arrived triangle. See this triangle. This triangle is called equivalent triangle. With respect to this original triangle, this is an equivalent triangle. If you see this newly arrived triangle without these points, this is also an identical triangle. But if you see the newly arrived triangle with these points, this is not an identical triangle, but this is an equivalent triangle. Further, allow the newly arrived triangle to another 120 degree rotation. Then the point 3 is shifted to this position, 1 is shifted to this position, 2 is shifted to this position. This is a newly arrived triangle. This is also an equivalent triangle with respect to the original one, because the points are different. Here 1, 2, 3, here 2, 3, 1. Then finally, allow this triangle to another 120 degree rotation. Further C3 operation, we may get an equilateral triangle with the points 1, 2 and 3. Now this is called an identical triangle because these two triangles are identical in not only the structure but also in terms of the points 1, 2 and 3. Then we may conclude that if you provide 360 degree rotation to an equilateral triangle, we can get the identical structure. But if you provide either 120 degree or 240 degrees rotation to an equilateral triangle, we can get an equivalent structure, not the identical structure. Now come to the symmetrical operations. If you provide the operations like E, C3, C32, then reflections through the medians sigma 1, sigma 2 and sigma 3, we can get the symmetry. Therefore, these operations may construct a group called point group. Now we will discuss the symmetrical operations one by one. The first operation is identity operation. Identity operation means do nothing or 360 degree rotation. If you provide 360 degree rotations, we can get the identical structure. Or no operation is carried out, we can get the identical structure. The points 1, 2, 3 are maintained as such. The next symmetry operation is rotation through an angle 120 degree. Say this is an equilateral triangle. If you provide 120 degree rotation about the vertical axis in the anti-clockwise direction, the point 1 is shifted to this position, then 2 is shifted to this position, and the point 3 is shifted to this position. So this is a newly arrived triangle. This triangle is called an equivalent triangle to this original one because of the difference of points. If you see this triangle without all these points, this is also an identical triangle. Anyway, we can get the same structure. Next operation is rotation through an angle of 240 degree. If you provide 240 degree rotation about the vertical axis in the anti-clockwise direction to this triangle, then the points 1, 2 and 3 are shifted like this. The 1 is reaching this point, then the point 2 is reaching this point, and 3 is reaching this point. That is, the point 1 is shifted to 2 positions. This first position, this second position. The same condition is true for all other points also. Anyway, we can get an equivalent triangle but not identical one. If you see this triangle without parentheses, without these numbers, that is also an identical triangle. And there is reflection through the median one. Say this is the first median. If the reflection is made through this median, the 2 points are interchanged. The point 1 is kept constant, here 1 is maintained as such, but these 2 points are interchanging their positions. So we can get the new triangle. This is also an equivalent triangle. Anyway, the symmetry is maintained. And next operation is reflection through the median 2. This is median 2. If the reflection is made through this median 2, the point 2 is fixed. But these points 1 and 3 are interchanged. 3 comes to this position, 1 goes to this position. See, this is the newly arrived triangle. It is also maintaining the symmetry, or it is an equivalent triangle. And the final one is reflection through the median 3. Say this is the third median. If the reflection is made through this median, the point 3 is kept constant, but the points 1 and 2 are interchanged. We have had a new structure that is also maintaining a symmetry. So in this way, the symmetry of an equilateral triangle is maintained.